Okay guys, welcome to the video for 6.3. In 6.1 we learned how to solve systems by graphing. In 6.2 we learned how to solve by substitution. And in 6.3 and 6.4, we'll get to 6.4 tomorrow or the next day, whenever. In both of these sections now we're going to be looking at elimination. So like I told you in the beginning, there are 3 ways, and this is the last one that we are going to learn about. And then if you flip ahead just really quick, 6.5 is all going to be applications. What did I tell you applications are? Your favorite word problems. Okay, so anytime you see the word application, it means word problems. But I'm getting off task here. Anyway, back to what we're doing. All right, so out of the 3 methods for solving systems, elimination is my personal favorite. I love elimination. It is very easy in my brain, at least. You know, I know not everybody is the same. Some people like graphing, some people like substitution. To be perfectly honest, I think all 3 of them are easy. It's just graphing and elimination tend to require the least amount of work. I guess it's kind of like why people like those 2 the best, because substitution, not that it's difficult, it just is a lot of steps, and it's very easy to get lost in what you're doing. But anyway, I'm rambling. So like I said, elimination is by far my favorite, and I don't have too many notes for us today, just some fill in the blank stuff. These are your steps for solving your systems by elimination. Okay, so this is important. You might want to make a little star next to this, so that you know that it's important. This is something that you can definitely reference back to if you ever get lost in what you're doing. Aside from these couple fill in the blank things, we're just going to jump into some examples because elimination is a little difficult to explain, and the best way to understand it is just to see it done, because once you see it done, you're going to get it. It should be easy. All right, so today we're going to start off with the adding and subtracting, and tomorrow we'll be multiplying. Okay, so your steps. You need to, first of all, make sure that both equations are in standard form. Do you remember a while back I told you out of all 3 ways to solve systems, each one of them tends to be the best choice for different circumstances. So for example, graphing is the easiest when both equations are in slope-intercept form. Substitution is the easiest when when one equation is in slope-intercept and one is in standard. And elimination tends to work the best when they're both in standard form. Okay, so I mean, you can honestly, you don't have to follow that criteria. You can use either of the 3 methods for any problem. It would just require a little bit of conversion from slope-intercept to standard or standard to slope-intercept. So, you know. Number 2, write the system so that the variables are aligned. So what I mean by that is, like down here on number 17, this x variable and this x variable in the second equation, you want them to line up. It's going to be the easiest when they are lined up, okay? Number 3, add or subtract the equations one part at a time. So one at a time, go through each variable and add or subtract. Now this part might get a little confusing because some people don't know when they should be adding and when they should be subtracting. Here's a hint. You should add when you have the same number with different signs. So what I mean by that is a 3 and a negative 3, a 5 and a negative 5, okay? And you should subtract when you have same number and same sign. Okay, so for example, same number, same sign would be 4 and 4, both positive. Because if you subtract 4 minus 4, they eliminate. It's 0, okay? So moving along, number 4, then you need to solve the equation with whatever's left. Whatever did not eliminate, you got to solve the rest of it. And then when you get your solution, plug it back into one of the original equations and solve for the other variable, just kind of like how you did in substitution, okay? So let's look at an example, number 17. We have 2 equations here, and yes, they are both in standard form. How can you tell? X and Y are on the same side of the equation together, all right? So let's follow our steps. Make sure that the equations are in standard form. They are. Number 2, write them so that the variables are aligned. They're pretty much already aligned, but it's kind of like slanted off to the side a little bit, and me being as nitpicky as I am, I'm gonna try to rewrite that. So I have 6x plus 6y equals 12. That's the first equation. Okay, and then we have a negative 3x minus 6y equals 6. So all I did, guys, is I rewrote the problems. All right, so nothing has happened so far. Okay, my third step says add or subtract one part at a time. And by doing this, you're going to be eliminating one variable. Okay, so how do you know when to add or subtract? Let's look. Let's look at the problem here. Which one of these variables, the x's here, or the y's here, have the same number? What do you think? You're going to notice that the y term right here, whoops, my highlighter didn't work very well, has the same number. They both are 6, right? And remember up here, I had you write down in your notes, you should add when they're the same number with different signs and subtract when they're the same number with the same sign. Here we have a positive 6 and a negative 6. So they're the same number, but different signs. So that means that we need to add these 2 equations together. Okay? So set it up kind of like an equation, and you're just going to go right down each column here and add them. So you have 6x plus negative 3x. That's just like saying 6 minus 3. So that's 3x. The next column, down the y's, you have 6y plus a negative 6y is like 6y minus 6y. And they cancel out. That's why this is called elimination, because you end up just completely eliminating one of the variables. And it works out really nice. So there is no y. You just have 3x equals 12 plus 6 is 18. See how simple that was? Now solve for x. That's what the 4th step says. Solve the equation. And the only thing we need to do here is divide by 3. And we get x equal to 6. All right? Step number 5. Plug your solution back into one of the equations and find the other variable. You can plug it into either one of these. You know what? Just so that there's no confusion on which one to plug it back into, let's just make a rule and say that you should always just plug it into the first one. All right? That way nobody gets confused. So I want you to plug it back into the first equation. 6x, but what's x? We just solved for x and we got 6. So 6 times 6 plus 6y equals 12. Okay? So this is 36 plus 6y equals 12. Subtract 36. I'm running out of room, so I'm going to move this up here, okay? So we're going to have 6y equals 12 minus 36 is 24, negative 24. And then divide by 6. And y is equal to negative 4. All right, there's your x and there's your y. Remember, you need to write it as an ordered pair, so this is going to be 6 comma negative 4. That's it. I love elimination. All right, let's do another one. Number 18, let's just follow our steps. Make sure both equations are in standard form. They are, x and y on the same side. Awesome. Write them so that they are aligned. I don't think I need to rewrite this one. It looks like they are pretty good aligned. Do you see why I rewrote this one? Because it was slanted. I didn't like it. These ones seem to be aligned pretty well, though, so I'm just going to leave it the way it is. Then step 3 says add or subtract. How do you know whether to add or subtract? Find the term or the variable that has the same number, and that's going to be here the y's. They're both 4y. And look at the numbers. Are they the same number with different signs or the same number with the same sign? Looks to me like they're both plus 4. They're the same sign with the same number, or same number with the same sign. So we got to subtract this one. Subtract. All right. Set it up like an equation. Now we have negative 8x minus 7x. That's going to be negative 16x. 4y minus 4y is 0. There's the elimination part of this. Equals 28 minus 28. Uh-oh. 0. And to solve for x, you divide by the negative 16, but who cares what you're dividing by? 0 divided by anything is 0. All right. So you're going to take your x and plug it back into that first one. And we've got negative 8 times x, but x is 0, so negative 8 times 0, plus 4y equals 28. Negative 8 times 0 doesn't matter. Anything times 0 is 0. So we just have 4y equals 28. And when we divide by 4, we get y equals 7. Okay. So the solution for this one as an ordered pair is going to be 0, 7. All right, let's skip 19 and 20. Those are for you. Let's maybe look at some on the back here. All right, 21. Yeah, okay. So let's line these up a little bit better. 6x plus 8y equals negative 4, and negative 8x plus 8y equals 24. All right, guys, I'm going to have you pause the video at this one. I want you to follow your steps that are on the first page, look and see which variable has the same numbers, and decide whether you should add or subtract, and then go ahead and solve for the variable and complete the entire problem, okay? Resume when you think you got it. So looking at this problem, I saw that my y variable had the same number with the same sign, so I chose to subtract. 6 minus a negative 8 is like plus, so 6 plus 8 is 14. And then negative 4 minus 24 gives me negative 28. It's like you're negative $4 and then you spend another 24, so now you're even negative more money. Divide by the 14, you get negative 2. Then I took that negative 2 and I plugged it back into the top one where x is, which is 6x. So 6 times negative 2 plus 8y equals negative 4. Solved it, did all the math, and I got y to be equal to 1. So I wrote it as an ordered pair. All right, let's do one more. Oh, number 22 has some weird stuff going on. Let's look at number 22 and then we'll call it a day. These are pretty much lined up just fine the way they are, so I'm not going to rewrite them. What would you do with number 22? You have to look, first of all, for which variable has the same number with either the same sign or a different sign. But you want to find the one that has the same number at least. And x both have 2, and the y's both have 4. So that's okay. Just follow your steps. In both instances, it's the same number with the same sign because these are both negative and these are both negatives. So what did we say in our notes to do when you have same number and same sign? Subtract. Okay, so we're going to subtract these two equations. All right, and we get negative 2 minus negative 2. Remember that double negative kind of makes it like adding. So this is really negative 2 plus 2, and that eliminates. Same thing here. Negative 4 minus a negative is like adding. So negative 4 plus 4, that eliminates too. So on the left side of your equation, all you have left is 0. Equals, solve the right side. We have 10 minus 6, which is 4. Now guys, does 0 equal 4? So this means that we have no solution. There's no solution to this system. Okay? So don't forget to do the last two problems on this side, plus 19 and 20 from the first side. You do have summary questions, so don't forget to do those. And I will see you guys in class tomorrow. Have a good night.